Hello, I am going to do your notes for the block day, February 27th and 28th. So today we're going to start talking about logarithms. So this is 3.3 logarithms. Okay, and at any time throughout this video, of course, feel free to pause it or rewind if I'm moving too fast for you so you can get everything written down, because I'm probably not going to leave time for you to write while I'm recording this. So, just kind of starting with the basics. A logarithmic function is the inverse of an exponential function. So, if you remember from when we did the function packet, inverse functions are reflections over the line y equals x. So, we just learned about graphing exponential functions. We know they go through the point 0, 1, and then 1 in the base. They kind of look like that. So if that is f of x equals b to the x, let's say, so it could be any base. Then if I have an inverse, remember they should be reflections over the line y equals x. So a log function actually looks like this. And it goes through this point, which is 1, 0. So this would be f inverse of x. So I'm going to use that f to the negative 1 notation for the inverse would equal log base b of x. So notice that b is the base in both the exponential function and the log function. But with logs, we write the base kind of as a subscript after the word log. So first thing we're going to talk about is just how to change back and forth between exponential and log form for any equation. So changing between exponential and logarithmic form. And pretty soon I'm going to stop spelling out logarithm. Okay, so changing between exponential and logarithmic form. If x is greater than 0 and b is greater than 0 and b does not equal 1, so we don't want to have 1 as our base because that's just not very interesting. We're only looking at positive bases when we're talking about exponential and logarithmic functions. Then, if you have y equals log base b of x, you can rewrite that as b to the y equals x, and it can go either way. So notice the base is always the base, and then basically the x and the y trade places. So when we write this in exponential form, it becomes b to the y equals x. Okay, so one thing I just always kind of keep in mind is the base is always the base. And then the other important thing to keep in mind is that the answer to a log is an exponent. So the answer to a log equation is an exponent. The answer to a log is an exponent. So anytime you're trying to solve a log equation, your answer, your y here, is actually the exponent for b. So when solving a log, or I guess I should say evaluating a log, ask b to what power equals x. In other words, your answer is the exponent, this what power part. That's your answer. Okay, but before we get too much into actually evaluating logs, I am going to do some practice with changing back and forth from logarithmic to exponential form. So for our first example, we're going to change or rewrite the log in exponential form. We'll do a few of these. So the first one, log base 3 of 9 equals 2. So I'm giving you like a true fact, a true equation. The log base 3 of 9 is always going to equal 2. And that's because when we write this in exponential form, remember the base is always the base. So base is 3. And then basically the 9 and the 2 trade places. So we'd have 3 squared equals 9. Remember the answer to your log is your exponent. So that would be your answer here. All I want you to do is rewrite it as exponential. Okay, so then like for B, I have log base 2 of 8 equals 3. So to rewrite that in exponential, it would be 2 cubed equals 8. Okay. And for the last one we're going to try here, what if I have log base 3 of 1/9 equals -2. So in exponential form, remember the base is always the base. So the base is 3. The exponent is the -2. And then equals this other number, 1/9. And that's true, right? 3 to the -2 equals 1/9. Okay, so then to go to the other way, so for example 2, once again, if you didn't get that copied down, feel free to pause. We're going to change or rewrite the exponential expression in log form. Okay, so for A, let's say we have 10 to the third equals 1,000. So we all know that's true. But if I wanted to write this as a log, I would write it like this. Log, remember the base is always the base. So the base here is 10. Log base 10 of 1,000 equals 3. And remember the answer to your log is the exponent. So the exponent becomes your answer. And that's all I'm looking for here. Just rewrite it in that format. Okay, and then B, so like 2 to the 5th equals 32. Okay, you would rewrite that log base 2, because base is the base, of 32 equals 5. Remember the exponent becomes your answer. Okay. I guess we can do one more. How about 4 to the -3 equals 1/64. So after all this work we've done with exponents, hopefully we all know this to be true, because 4 cubed is 64, and since it's negative, it goes to the denominator. So if I wanted to rewrite that in log form, the base is 4, right? Base is always the base. And then we switch these two, the -3 and the 1/64. So I have log base 4 of 1/64 equals -3. And the exponent becomes your answer, once again, for the log. Okay. So now that we've kind of practiced going back and forth, because that's just going to be something you need to be able to do relatively easily, we're going to look at the actual types of examples, or some of the types of examples that you will be doing on your homework. So we're going to actually start evaluating some logs. So it's finding the answer to some logs. So for example 3, you are going to be evaluating, so I'm just going to say evaluate the logarithm. So remember, you're looking for the exponent because the answer to a log is always an exponent. Okay, so first one is log base 2 of 8. And I want to find the answer. I want to find what that equals. Okay? So remember, the answer to a log is an exponent. So what I'm actually asking myself is 2 to what power is 8? 2 to what power is 8? Okay, and so we know 2 to the third equals 8, right? So that means that the answer to this log is 3. Okay, so that's it. You're just answering the exponent. 2 to what power would give me 8? So the answer to a log is an exponent. Okay, for B, log base 3 of the square root of 3. So another way you can solve these, you're still asking this question. So like 3 to what power will be the square root of 3? But one thing you can do is actually just set that equal to x. And then if you rewrite it in exponential form, so 3 to the x equals radical 3, then you can just solve for x. So I'm still asking, just like I did over here, 3 to what power would be square root of 3? And I would get 1/2, right? Because 3 to the 1/2 power is square root of 3. So you don't have to do it this way, but it's essentially what you're doing. Every time you're solving a log, here or here, you're asking, you know, the base to what power equals this number that you're taking the log of. That's why it's like kind of the opposite of an exponential equation, or the inverse. How about this? Log base 5 of 1 over 25. So 5 to what power equals 1 over 25? Wouldn't that be negative 2? Because 5 squared is 25, but it went on the denominator. So this is because 5 to the negative 2 equals 1 over 25. So you're still answering the question, what is the exponent that gives you this answer? Let's try 1 or 2 more. So I'll jump down here. For D, how about log base 4 of 1? So I'm asking 4 to what power equals 1? So if I do this trick where I set it equal to x, I'd have 4 to what power? 4 to the x equals 1. So what would x have to equal? How about 0? Because anything to the 0 power is 1, right? So this is going to be kind of a general rule. Because anything to the 0 power equals 1, the log with any base of 1 is always 0. And we'll kind of write this down as a rule in a minute. Okay, so then my last one, how about log base 7 of 7? So I'm really asking 7 to what power equals 7? So wouldn't that just be 1? Because 7 to the first is 7, right? So there's your answer, that 1. And this is also kind of a general rule. Anytime you take the log of the same number as the base, you'll always get 1 as your answer. Okay, so at this point, I want to go ahead and write down some of these basic properties. Excuse me. So basic properties of logarithms. And there are just 4 that we're going to write down for now, and then we'll do a few more notes and a few more examples. So the first one is log base b, so that means any base of 1 is always going to equal 0. So it doesn't matter what the base is. Anytime you take the log of 1, you get 0, because b to the 0 power, no matter what b is, anything to the 0 power always equals 1. All right, for any base. So similarly, that's like this example we did up here. Also like the example we did up here on part E, right there. If you ever do the log base b of b, you're always going to get 1, because b to the first is always just b for any base. So that will always be true. How about this? What if you have the log base b of b to the y? Kind of weird. Well, that's always just going to equal y. It's kind of like the log base b and the b cancel each other out. But the reason why is because the answer to your log should always be your exponent. And look here, y is the exponent. So if you were to rewrite this in exponential, you'd have b to the y equals b to the y. So because b to the y will always equal b to the y for any base. And then finally, if you ever have b raised to the log base b of x, you're just going to get x. So it's kind of the opposite of the one before it. Still, like b raised to the log b, those cancel each other out essentially, and you just get x. And the reason why here is because if you were to rewrite this equation in log form, you'd have log the base is b of x equals the exponent, which is log base b of x. So it all works out. So those are our 4 basic properties. A couple other things before we finish our examples for this lesson. There are 2 bases that I'll say are special. And these 2 bases are 10 and e. Okay? So the common log, that's the name for it, is base 10. So when you see the log button on your calculator, it's talking about the common log with a base of 10. So if you ever have the log base 10 of x, it's just written log x. So if no base is written, we just assume the base is 10. Which is why, like I said, that log button on your calculator will always be log base 10 because it doesn't have a base written. And then the other one is called the natural log. And that is base e. So I know e seems super random, like why is e so special when we do logs and exponentials? And we'll kind of explore that a little bit more when we get to word problems and applications. But for now, just know that the natural log or a base of e is kind of a special log. E is just an irrational number, kind of like pi. Irrational numbers have infinite decimals that never repeat. And e is approximately equal to like 2.72. But it goes on forever, just like pi. And we'll look at why it's special sort of in the future. So a natural log is written like this, ln of x. Okay, so that's just a fancy way of writing log base e of x. So we'll never write log base e. We always write it as natural log x. So anytime you see natural log x, that means the base is e. Okay, so we're going to practice evaluating common logs and natural logs. So when the base is not explicitly written. So this is example 4. Evaluating common logs, and natural logs. So I'll just kind of write these out. For A, I'm going to do the log of 100. For B, log of the 5th root of 10. For C, the log of 1 over 1,000. For D, the natural log of the square root of E. For E, the natural log of e to the 5th. And I think we'll stop there for now. Okay, so remember, when the base is not written, we assume the base is 10. I'm going to grab this other color. So we assume that that base is 10. So I'm asking myself, 10 to what power would equal 100? So wouldn't it be 2? Yes. So 2 is our answer. Remember, our answer is the exponent. It's the power. So for this one, I'm asking 10. So remember, if the base is not written, it's assumed to be 10. So 10 to what power would be the 5th root of 10? So 10 to what power, put an X, put a question mark, would be the 5th root of 10. Wasn't the 5th root of 10 the same thing as the 1/5 power? So our answer is 1/5. And then this one, 10 to what power is 1 over 1,000? Well, I know 10 cubed is 1,000, but since it's in the denominator, I need to make that -3. Okay, so that's all we're looking for. Remember, we're always looking for an exponent when we solve logs. Okay, so I have a couple natural logs where the base is e. So this first one is asking e to what power? E to what power equals the square root of e? Well, I know square root is a 1/2 power. So your answer there is 1/2. Okay. And this last one, e to what power is e to the 5th? So e to what power is e to the 5th? And so the answer here is just 5. So another way to think of this is that like the natural log and the e essentially cancel each other out, and we're just left with 5. Okay. So remember, any log where we have the same base as this number, they kind of cancel each other out. Sorry, it's off the screen. Okay, so one last example. This is exponents. Oops, I skipped the X. Exponents to a log. So using one of these properties that we wrote down. So we wrote down here, we have an exponent raised to a log with the same base. They essentially cancel each other out. So I want to try that out. So for A, let's say we have 6 to the log base 6 of 11. Okay? We want to know what that equals. The 6 and the log base 6 cancel. Our answer literally is just 11. Because remember, exponentials and logs are inverses, so they cancel each other out. Okay, so for B, if I have 10 to the log 6, once again, remember the base here is 10 since it's not written, so the 10 and the log cancel, and we just get 6. And it works with e's also. So if I have e to the natural log 4, let's say, the e in the natural log, because the natural log is a base e, they cancel each other out, and we are just left with 4. Okay? All right, so I think that about does it for the first set of notes for today. So this first assignment is going to be on page 281, and you're going to work on numbers 1 through, let me make sure I get this right, 1 through 24 all. And I know this sounds like a lot, but they go by pretty quickly. I mean, you can see these last 3 problems. Those would go real quick. So just practicing evaluating logs. Remember, your answer is always an exponent. All right. Happy math. I'll see you guys on Thursday.